Okay, so Unit 2, Lesson 4, periodic table. What we have to do today is classify the elements. So this second half of the unit, a lot of times in the prior years, I've been teaching chemistry for 11 years, free chemistry, and students almost always say that the second half of the unit is easier than the first half. One of the reasons is because some of this may be already quite familiar with. Like where are your metals on the periodic table versus where are your non-metals. And so some of this hopefully is review. If not, we are going to be learning how to classify elements based on their placement in the periodic table because elements in similar areas have similar properties. And that's going to be important for us to be able to draw conclusions about elements. So once again, write down the lesson title, Unit 2, Lesson 4, Periodic Table Classification of the Elements. The same slide should be showing in Nearpod. I'm going to go over there to just double check. Yeah, the same slide should be showing in Nearpod. There will be a couple of questions where you will have to answer for participation on Nearpod as we go along through today's lesson. You'll also want that periodic table, the paper one. It's one of two you're going to fill out today. You're actually going to get two periodic tables today. One earlier, one later for different things to look at on the periodic table. So here we go. Unit 2, Lesson 4, periodic table. Today we will classify the elements. So somebody in the last class said more magic tricks. More things the periodic table can do for us. So the first question is, how is the modern periodic table organized? You don't have to write the full chart, but you should write the questions. How is the modern periodic table organized? It's organized in a specific way for a very specific reason. And it used to be organized differently. Back in the day when Mendeleev proposed the periodic table, he proposed a periodic table that was by increasing atomic mass. And it is no longer organized by increasing atomic mass. And there's a very good reason why.
That's increasing atomic number?
It's by increasing atomic number. And so you may notice that, well, doesn't the mass increase as you go left to right? Like, as the atomic number increases, the atomic mass also increases. But there are some notable exceptions. I want to point to your attention. Look at argon and potassium. Argon is 39.9. Potassium is 39.1. 39.1 is less than 39.9. So on Mendeleev's original periodic table, these two elements would have had switched positions. And so potassium would be where argon's at, and argon would be where potassium's at. Well, that's a problem because one of the things you're going to learn is that all the elements in this group, they all explode on contact with water. Argon doesn't do anything. Argon's a noble gas. It is completely unreactive. So they discovered that the order in increasing atomic mass wasn't quite right. And so they reordered the periodic table to be by increasing amount of protons in the nucleus, which we call the atomic number. And this places argon in the correct position with the other gases that don't react. And so how is the modern periodic table organized? It is organized by increasing atomic number, which is the increasing amount of protons. Because every element has a different amount of protons. And so this differentiates each element from each other. And also we end up grouping elements into areas that have similar characteristics. And so like someone said earlier, it is quite magical in a way that it ended up working out this way. Elements that end up in the same column have very similar characteristics. When we organize the periodic table by increasing atomic number or increasing protons. And so today what you're going to have to memorize, and that's what the coloring is going to help you out with, is the areas of your periodic table, the different names of the groups, and whether an element is a metal or a non-metal. But before we do that, I've been calling these rows and these columns, because I hadn't taught their official names yet, but we're going to now talk about what are the names of the rows on the periodic table, what do we actually call them, and what are the names of the columns on the periodic table. We actually have a different name that we reference them by. Are we good here? Yes. Yes. Go ahead, grab a pass. Before we do that, this is just a definition you need to know. Write it down. I'll give you some time. when we organize elements by their increasing atomic number, we end up with something called periodic law, which means that there is in every row a periodic repetition of physical and chemical properties of the element. And I think I had went over this before, but I'm just going to go over it again just in case. What is the difference between physical and chemical properties? I think I've mentioned this, but it's assumed that you know this from like an 8th grade science class. Just in case. So when elements are arranged in order of increasing atomic number, there is some repetition of their physical and chemical properties based on their placement in the periodic table. I'm giving you some time to write this down, and then let's talk about what are some physical properties, what are some chemical properties. What are we talking about when we talk about physical versus chemical properties? And then let me make sure on Nearpod I've moved forward. There's no questions to answer yet, but just to match the slides. So physical properties. What's the general idea about a physical property of an element? I talk about a physical property, or you talk about a physical property. We're talking about magnesium, for example. What are some physical properties? What is that? So it's density. Density is an example of a physical property. Okay, what else? Volume is a property, but it's part of density, so I'm going to leave it out. Mass and volume are both part of density. What are the physical properties? If I look at a piece of magnesium, what do I know about it? Yes.
Shape.
Shape, color, right? Shape,
Color.
color. If I put a U there, it's British, right? Color, shape, but we are in a British curriculum. Density, shape, color, what else? Mass is part of density again, so I'm going to leave that out. What about state of matter? Whether that element exists as a solid, a liquid, or a gas. What about its ability to conduct heat or electricity? Is it a material that transfers heat well, or is it a material that's an insulator? So we could talk about conductivity. Does that material transfer heat? Does it transfer electricity well? Those are examples of physical properties. What's the main idea of a physical property?
Like how it looks like.
Just basically what it is, right? We're just talking about what it is. It's silver, if I'm thinking about magnesium. It exists as a solid. It can be drawn into a wire, right? Those are all physical properties. When we're looking at what we have in front of us, we're just making an observation about it. So then what's a chemical property? Yes.
Flammability.
Flammability. So anything that discusses how this material reacts. So all you've got to know is how the material reacts. And so flammability is a great example. Flammability, oxidation, does it oxidize? Is it explosive, right? And I set it on fire. Will it be oxidized? Is it explosive? There's other words. But just the idea, I just want you to have the ideas in place. Physical property is, I'm looking at it, what does it look like? Chemical property is, how is it going to react? We can actually predict both the physical properties, what the observation of an element is, what it looks like, and how it's going to react chemically based on an element's position in the periodic table. And so that's why it's so important we go over these properties, because it gives us a lot of information as we move through the class about how an element is going to behave. So far, so good? All right, make sure you have this down. I'm pretty sure I went over this earlier in the year. I'm going over it again. It's technically not something in the standards because it was supposed to be taught in an earlier year of science, but I always like to go back over vocabulary that might be confusing. Okay, so the first thing we've got to know, this is new terminology. Maybe not new for you, but probably, it could be. Periods are what we call the rows. So in the periodic table, when we're looking at a row of the periodic table, we actually call it a period from now on. So instead of saying row 1, we say period 1. Instead of saying row 5, we say period 5. Groups are the vertical columns. And so you want to make sure that if you struggle with the wording, vertical means up and down, and horizontal means
Left to right.
left to right. So when I'm comparing a period, I'm comparing elements left to right. And when I'm comparing a group, I'm comparing elements top to bottom or bottom to top. Make sure you have that written down because students do get confused about this. People get confused. And so the visual may help. On your periodic table that you're going to write up on today, the first one, the first thing we're going to want to do is number our periods. Notice on the Cambridge periodic table, they have not numbered your periods. So we should start by doing that. And we've done it before, actually, when we were numbering them for energy levels. So on here, did everybody get to write down periods and groups?
Yeah.
Yes. On here, fill in, where's row 1? Where does it start?
On top of lithium.
It's hydrogen, right? So this periodic table to me is a little bit confusing in that way because hydrogen is not written on the side. So if you're not looking carefully, you may forget that that's actually row 1 and you accidentally start row 1 in the wrong place. Row 1 or period 1 is with hydrogen. Go ahead and fill out these numbers. 1, 2, 3, 4, 5, 6, 7. These are called your period. Write that down. Period. Go 1 through 7. And notice the way that the Cambridge periodic table is organized. They wrote group at the top. They're telling you the groups are the ones at the top. So you've got group 1, and it goes to group 18. So periods go from 1 through 7, and groups go from 1 through 18. Yes.
What about the groups for
They're quick.
for 57 to 71 and
So 57 and 89 would be here, right? And then these technically don't have their own group in this version of the periodic table. There is a long form of the periodic table that actually stretches out like this and has 32 groups instead of 18. Why do you think 32? It's actually a number that might make sense. This periodic table has 18 groups. So I'm saying there's another version of the periodic table that would include these and put them all in here. That would stretch it out. That would be 32. What's the difference between 18 and 32?
oh wait, because
Go ahead.
it adds 28 elements instead of
No, it adds 14 groups.
yeah, but like
It adds the whole S block.
the two combined apps add 28.
Right, but I'm talking about the groups, which are the columns. There's 14 more here. This has 18, which means I'm including only my S, my P, and my D, which we know S and P and D all add up to 18 electrons, 18 groups. It has to do with what we were learning before. Anyways, your groups are 1 through 18, and your periods are 1 through 7. And these are for all known elements. So period 8 would be where your first non-existing element or energy level 8. So, first task. See if you can find, and this is basically looking at the periodic table like it's coordinates. Looking at the period and looking at the group, can you find each of these elements? Provide the chemical symbol. I'm going to write the chemical symbol when we do this. So let's do this one together, and then you're going to have one to do after this on Nearpod. A set to do. So chemical symbol, period 3, group 15. How do I find this element? Remember, periods are the rows, and groups are the columns. You may want to write that until you've got it. Periods are the rows, groups are the columns. So period 3, group 15, what element is that? Yep. The third, and you go to group 15, and it's right there. It leads us to phosphorus. Period 4, group 2. And yes, there will be at least 1 or 2 questions on your unit exam that are like this. So make sure you know it shouldn't be that hopefully it's not that complicated. But there could be a multiple choice or a written question. Period 4, group 2. What is this? CA. Period 6, group 17. Period 6, group 17. So AT. And period 4, group 7. Period 4, group 7. What's that?
Manganese.
Now let me make a point, and you may want to write this in your notes. When you are writing the chemical symbol, only the first. So when writing chemical symbol, only the first letter. Is capitalized. So if you write, for example, KR in a noble gas configuration, this actually is not krypton. This is potassium, and R is something that doesn't exist on the periodic table. So this is absolutely wrong. I was kind on the quiz, and I did not count it wrong, but I'm telling you explicitly now, if you capitalize the second letter in a noble gas, it is wrong. It is not that element. Every capital letter indicates a new element. This matters because we're about to move to compounds. And when you have a compound, you're going to have something like this. CO, if I see a capital C, capital O, that is carbon monoxide. You breathe that in, you die. Capital C, lowercase o is cobalt, a metal. So just capitalizing or not capitalizing the O actually changes everything. That's why I said in chemistry, we are picky. We are very picky, and there is good reason. When you're communicating with symbols, you have to communicate properly. This is carbon monoxide. This is carbon dioxide. Yes?
To be fair, if you breathe in cobalt, I'm pretty sure you're also going to die as well.
You can't really breathe in a pure metal. Like it's like breathing in a block of iron.
Yeah, but like a little piece of it.
You probably shouldn't ingest it for sure.
Yeah.
But I'm just saying, carbon monoxide is a colorless, odorless gas. We'll talk more about it when we get to compounds. But I'm just saying that you have to be careful when you're writing your chemical symbols. I'm going over this now, so when you take the unit exam, you gotta know, when you write your chemical symbols, it's only the first letter. If there's 2 letters, you capitalize it. There is no excuse for getting this wrong. You have a periodic table provided by Cambridge that has everything on it. Everything done correctly. So don't do it wrong.
Everything except periods.
Right, pretty much. And that's why we have to look at what it gives us and then fill in what it doesn't for the things we have to know. All right, so that's the first thing. Identifying periods and groups. It's your turn. On your pod, your first exercise. I'm going to give you a few minutes. This is going to be a sorting activity. On Nearpod, there's a sorting activity popping up now. It should pop up on your Nearpod on everybody's screens. You've got a couple of minutes to now look for the periods, look for the groups. I believe I have it reversed.
It doesn't work.
Yeah.
Yeah, it shows the sad picture. Sad picture.
See if you can refresh. Is that to
Because
everybody?
I'm trying to refresh right now.
Oh, sad.
Yeah, it didn't work for me.
I guess we'll have to skip the
And
first
it's
activity.
waiting. It's reloading right now.
Maybe if I go back and forward,
Yeah, probably.
let me refresh my page and see if it
Oh,
works.
right. It just doesn't have that paper.
I saw it. Reload it now because it works on Oscars. I saw a couple people at work for it. Is it the school computer? Because you're not a school computer, you are a school
Yeah.
computer. It's the school computer.
The
isn't
school
it?
computers suck.
Yeah, now it just shows a white screen.
Yeah, now
Yeah,
it's
it's
even
like-
worse now.
Doesn't even know it.
I would try a different browser. Let me know what works. Try a different browser, see if it works. If you are on a school computer. Enter the same code. You have to find the element. Are you on a school computer? Is it working or not? Go to a different browser.
It's now it says
Right,
403
Firefox.
forbidden.
That's what everybody else thinks. I think I'm just gonna have to stick with them. Those of you who are on school computers, unfortunately, can't do this question. But it was the same idea, except that it was groups first and period second.
Let me try to go
Okay.
in again.
All right, next thing. The information a period versus a group gives you. Some of this I already told you. And one of these things are new, and I bet you wish I told you. But I didn't because I wanted you to figure it out by thinking about it. So, the period for any element tells you the principal energy level. What is a principal energy level?
Something like that.
So it's the highest energy level for that element. So for example, I know calcium is in period 4. It goes up to energy level 4. Its electron configuration goes up to energy level 4. Its final electrons are in energy level 4. That's what the period tells me, the row. Believe it or not, the group actually can give away your valence electron for S&P elements. So you do not have to write out the electron configuration to figure out valence electrons if you know the following information. For group 1, the amount of valence electrons is always going to be, for group 1, the valence electrons are always going to be 1. For group 2, the valence electrons are always going to be 2. For group 13, you take away the 1 in front because you have to take away the D block. So you take away 10. And how many valence electrons would every element in group 13 have then?
3.
3. Everything in 14 has how many valence
4.
electrons? Everything in 15 has how many
5.
valence? And it goes like that. And you can do your valence electrons now in 15 seconds. Just how long it takes you to find the element. Write this down. We'll practice with this in a little bit.
So wait. Speaking of like a 32 one, wouldn't
Yeah.
that mean that it would be 32 electrons in one?
32 electrons is in the 4th energy level, but if you'll recall, both the D and the F blocks are not in the principal energy level. The D and the F blocks, you have to subtract 1 from the row for the energy level those electrons are in, and you have to subtract 2 for the F block. So no, only for the S&P elements can you figure out the valence electrons. The S&P blocks. Which, thankfully speaking, are 95% of the elements we work with in the class. Most of the time we will be working with elements in groups 1, 2, and 13 through 18. And so that is the simplest elements to work with. Now, I don't know if you recall, but I had told you after Unit 2, when we're done with this unit, starting with Unit 3, we're only going to look at valence electrons, actually. You're going to forget the other electrons exist, the core electrons. Because the valence electrons are the only ones that are shared or transferred by elements to make compounds and in chemical reactions. So yeah. How many valence electrons does arsenic have then? Can you figure that out?
Yeah, 5.
How many valence electrons does iodine have?
Seven.
Right? How many valence electrons does bismuth have? Bismuth.
5.
5. Got the idea?
Mhm.
So for groups 1 and 2, it's literally that number. In groups 13 through 18, you just take away the 1. Because you have to take away the 10 D groups. And that tells you how many valence electrons you have. And it's because that means work to figure it out on the quiz. But the good news is for the unit exam, which is the bigger grade, if I now ask you valence electrons, you can figure it out in a jiffy. All right, I'm moving forward in about 20 seconds. I think, let me double check where we're at. We're going to write one more thing down before we go to lunch. Before we go to lunch, there's one more thing I want to bring up. Elements in the same group. This is the last slide you're going to write on before lunch, where we're going to return. Elements in the same group have similar physical and chemical properties. So we can actually draw conclusions about how an element behaves based on the group of the periodic table it's located in. The reason why these are called the noble gases, group 18, which is the only one we've a little bit looked at, is because they don't react at all in a chemical reaction. They're stable because they have their core electrons filled in their energy level. And so, based on an element's position, we can actually determine, based on the group that an element's in, how it's going to behave, and for metals, a lot of its physical properties. So, make sure you write this down. This is where we're going to stop heading into lunch. One of the first places we're going to go when we come back is marking up your periodic table in the different groups and what they are.
Actually, what do you guys? I'm sorry, but look, then I can use my other power when I need it to. Then we mess up my entire piece. Yeah, but no, it's literally skills. You have to do so many stuff to get that.
Are you talking about the quizzes?
Yeah, fragments. I got first, but then I helped him, so then he got first, but I'm second. Even though of the glitch that happened to me, I still got second. It's so over.
See?
They
What's the
it's
point?
2 times
What's the
harder.
point? Like, they will literally do nothing.
Yes. No, it's skill.
He wants the 1 extra point.
Pure skill.
Not skills. It's just points. Power up.
It's resource management. That's what it is.
Yeah, Kevin.
Most teams teach resource management. They have to solve for extra, like they had
Yeah, why don't you do it?
Yeah, so after it gets done,
Hi. Robert, are you going to be taking your quiz today after school? Robert? All right, go ahead and head to lunch. Yesterday was Monday. I waited.
I forgot.
Oh, yeah, you can't come today after school, right? Can you, the next time I have is Thursday. You can come Thursday after school. Can you come Thursday after school?
Alright. I can put a reminder.
Okay. Well, it's an exam, so an hour.
NC.
I'm sorry?
Do I say NC?
If it's got stuff, you can move to an empty seat. All right, let me go ahead. Leah, this is just for you to finish the, because you had left a little bit early. And then from Mary Shell. You have to take a full exam. So you can take it over 2 class period, like 2 lunches if you need to. You could do the multiple choice today and then do the written part a different day. That way you have the full time. Okay, just let me know which day you will be coming back.
Okay.
You can get a calculator as well if you don't have one. You're welcome. And you can sit at your normal seat. Nobody sits there in 4th period actually. That's 4th period's a pretty small class. What happened? You need a pencil?
I'm at being 6.
I'm at B first. I guess
Kevin.
Right now. Like,
And literally,
like that, yeah.
what? You feel that, yeah. Thank you so much. Sarah. You don't even look alike.
Bro, why Sophia left you?
No, bro.
She has her whole life like this.
No, well, see, just look at it. Does it count? Does it matter?
hype us back up. All right, so no, you don't have to memorize the whole song. You don't have to memorize the whole periodic table. Remember that you get this from Cambridge, so you have to be able to read this periodic table. So what we're going to do now is we're going to diagram it into different areas. So take a look. This is our blank one. This is our blank canvas that we're going to write over. Before starting, you should go ahead and write this in your notes. There are specific group names you need to know. We will refer, and by we I mean Cambridge International, we'll refer to specific groups by specific names. So you may notice the A here. You don't have to write that. It's just group 1 and 2. There's a different definition of the periodic table that splits your elements into A groups and B groups. The A groups are the representative elements, which we're going to talk about in a little bit. But you can just remember group 1 is the alkali metals. Group 2 is the alkaline earth metals. Group 16, 17, and 18 you also need to know by name. 16 is called the chalcogens. 17 is called the halogens. And group 18 is the noble gases. Those 5 I would write down. We're also going to identify them on our periodic table shortly. But I'm starting with this first so you have them to go back to so you know how the spelling is, just because it's really small. Yeah. Everything that we diagram in the periodic table, you're going to have to memorize. So the diagramming is just to help you memorize.
And there's nothing in group 3.
Group 13. Is this group? Group 3 has a name you'll see in a little bit. But we're starting with group names you need to know. Then we're going to start diagramming our periodic table. So have your colors ready. Have your printed periodic table, the one that I gave you early today in class, ready. The next thing we're going to do is we're going to start coloring it in. You need at least 6 different colors. At least. At least. You can double colors if you need to. Greater than or equal to 6. There will be more. If you look here, there's actually 9 different designations. We're going to recreate this from scratch, though. So here we go. And then I'm going to, of course, give you the notes afterwards. After school tomorrow, I'll be posting them on Google Classroom if there's anything that you missed, or for anybody who's not present. But let's go ahead and start from scratch, because that's the best way to build it up. First group, group 1. And so remember the way it says it here is the groups are going to be your vertical columns. You may want to remember that for yourself. And on the one you wrote earlier, you wrote your periods already, right? 1, 2, 3, 4, 5, 6, 7. Remember your periods are the rows. We look at period, we are talking about the row. And groups are the vertical columns. So the first group, pick a color. We need to color in group 1. Group 1, I'm going to pick like a goldish orange. Group 1 is called our alkali. What? I would not say that hydrogen is an alkali metal because hydrogen is not a metal. So no, I would not put hydrogen. The Cambridge periodic table breaks hydrogen off to the side because hydrogen doesn't really have a group. There's always a rule and a rule for hydrogen. You'll see why through the year hydrogen is different. Part of why you'll learn today. So your first group, you should shade these in, make an outline, and then shade the elements in. These are your alkali metals, starting at lithium and going down to francium. Make sure you're following along and you're shading this in. This is what you're going to use as you're studying for next week's unit exam. So group 1, alkali metal. I wrote it light here, that's why I had you write it in advance. Group 1, alkali metals. Somebody asked in the second period class, why are they called alkali? The reason why they're called alkali is because all of them in water, all those metals in water form very basic solutions. You may know what acids and bases are, you may not. We're going to do a unit on it later this year. But a basic solution is one where you have a lot of hydroxide, OH minus, in the solution versus the amount of acid in the solution. So all you gotta know is that when you see that word alkali, it means you're gonna have a strongly basic solution out of those elements when they're put in water. They also all explode. That is a defining characteristic of the alkali metal. It'll come up. The next group is called the alkaline earth metals. You will need to know that they're highly reactive. Next class we'll be talking about the periodic. So our second group, you call those the alkaline earth metals. Alkaline is like alkali in that they do make strongly basic solutions. The alkaline earth metals, however, are not as reactive as the alkali metals. They include some famous elements like magnesium and calcium.
Wait, alkali and alkaline.
Alkali and alkaline. An easy way to memorize it is alkali has less letters and it comes first. Alkaline has 2 more letters and it comes second. Yes.
Does your periodic table technically show it all?
If you can see it from where you're at, yeah. Or I can cover it on the day of your unit exam.
No, don't go.
You're supposed to memorize it. I usually do cover it on the day of the unit exam. Heads up. The one in the front. I don't think the Star Wars one has them notated the same though. All right. The next group you've got to know by heart is we're skipping all the way to group 16, right? So we skip all the way to group 16. That's got some famous elements such as oxygen and sulfur. That group is called the chalcogen. Like chalk, yeah, chalcogen. I don't remember what that comes from. Why it's called the chalcogen. So definitely an older name. All right, group 17. This is a very, very famous group. They are called the halogens. And you may have heard of halogens before if you've heard of like halogen lamps, halogen light bulbs. Halogens include fluorine, bromine, and iodine. Yes,
The alkaline metals are the ones that explode in water,
they do.
not alkaline.
They do not. Because alkaline earth metals are not as reactive as alkali. We're going to learn why next class in the periodic trends. Yep. And this final group, group 18, is the only one that you at least semi knew before today. What were they called again? We used them for electron configuration. They're called the noble.
That's
Yeah.
That tells us they all have the same state of matter. They're all gases, and you can figure that out just by their name. These are the noble gases. So the reason why they're called noble gases is they're in the gas phase, and they're noble because they don't react. They actually are not chemically reactive at all. So helium is not chemically reactive.
they're noble, so that means they're a good person. A good actor.
They're not explosive. They don't do anything. So those are the first 5 groups that you have to know about. But there's more. You're going to have to place an element into exactly where it belongs. So there's a lot more elements than just the elements in these 5 groups. So we're going to classify the next section. I'm just pausing to give you some time to color in. The next section is something you're at least semi-familiar with. The D block metals. From what we learned when we did the electron configuration, this block all has its own name. The D block metals. So these metals all in here, they all have their own name. They're called the, that's not their name. They're called the transition metals actually. But they are all the metals that are in the D block. They're called the transition metals. Should we be including lanthanum and actinium here?
Probably.
They are part of the D block metals, right? And so those are what we call our transition metals. Make sure you shade in D1 through D10. The whole D block gets shaded in one color. Every single one of those metals is called transition metals. Now, the word transition, what does that mean?
They change.
It means that there's some kind of change happening in those metals. The way you can think of transition metals, they're more complicated metals. Most of what we're going to work with in this class are the alkali and the alkaline earth metals. We will work through the transition metals sometimes, but whenever transition metals enter into the conversation, whatever we're going to have to do is going to be a little bit more complicated. A full discussion of transition metals doesn't take place until an A-level study.
Oh.
But we know they're there. They're in the middle section here. We already know they're more complicated because when we do their electron configurations, we have to go from 4S to 3D. That's already more complicated. So every time we have to talk about transition metals, just know the conversation gets a little more complicated. What about the F block metals? They have their own name too. The F block metals. This section is called the inner transition metals. So the inner transition metals are down at the bottom. The transition metals are the D block, and the inner transition metals are the F block. That's an easy way to remember it. We've now covered most of our elements. We have just a little bit more to look at. I'm pausing to give you time to shade it. I know it takes time. The most shading of life. All right. The next thing you're going to do is very, very important. You're going to want to pay careful attention to how I do it. You may want your darkest color or a pen for what I'm going to show you now. Starting at the top left-hand corner of boron. So make a mark there for yourself to remember. You're going to create a staircase. What do I mean by that? You're going to go down one line, and then you're going to go to the right one line, and then you're going to go down one line, and then you're going to go to the right one line. And you're going to do that over and over and over again until you reach the end. So like this. Down to the right, down to the right, down to the right, down. See what I did? The staircase, where you started is the most important thing. At the top corner of boron. Then you go down one to the right one, down one to the right one, down one to the right one, down one to the right one. This is an extremely important line to memorize because this is the dividing line between your metals and your non-metals, actually. So this black dividing line is the dividing line between metals and non-metals.
Wait. So do we keep things like polonium still marked?
They're still chalcogens. That's why I said write your darkest color. You're not filling in those elements. You're just writing a line on the edges of the boxes, if that makes sense. That's your dividing line. What that means is that all the elements that are to the left of that line are metals, and the elements that are to the right of that line are non-metals. Keep that for now. Because we're going to need a separate chart for metals and non-metals. But you at least have the dividing line here. The reason why I'm using it is because I need to identify one more section. There's one more section to identify before we move forward, and that's called the post-transition metals. So pick one different color if you can. And aluminum, gallium, indium, tin, gallium, lead, and bismuth. And these, you include those. Those dark blue squigglies are called your post-transition metals. Yes.
All the metals to the left of the line are, wait, the ones to the left of the line are metals to the other ones.
Right. That's what I wrote in black. And you're gonna see that again shortly.
Okay, and so then it stops at business.
The post-transition metals, yes. Let me double check with the one here. Yeah. They call them here other metals in this one. But yeah, those are the ones we call it post-transition.
And now polonium.
Yes.
So wait, why is your periodic table kind of different
Then which one?
than that?
This is not my periodic table. Even though it's in my classroom. It was bought before I got here. So whoever ptable.com is made this. The one that we need to follow is the Cambridge one, the Cambridge periodic table, which is the laminated one which is the same one that's here. This is the one that we have to interpret. Oh, are you asking why these numbers are missing? Because it's older. These numbers 113, 115, 117, 118, they're missing on this one because this one was printed or copied before 2018. That's the only reason. 2018 is when they finally filled in the rest of the periodic table.
So wait, we don't fill out germanium or
Nope, they have their own designation. They're called
Oh.
metalloids, which we'll learn about in a little bit. So this is classifying your groups. I've ran out of space, and I don't want to double color or anything, so that's why I said you're actually going to need 2 periodic tables today. One for your regular classifications, and then you're going to need another one for metals, non-metals, and metalloids, which we're going to look at shortly. First, finish shading this in. I'm giving you about another 2 minutes, and then we're going to move forward. While you're waiting, if you are done, see if you can, if you are on a school-issued device, reset your computer. Make sure that you've downloaded the updates. And see if the Nearpod will work for the next question.
I think I just need to switch browser.
Okay.
I mean, it's the same browser, so like.
It works.
Maybe it's just that question.
Maybe. We're going to try a different question a little bit, so. All right, 1 minute, and I'm moving forward. Okay. Just to double check. And troubleshoot technology issues. All right, moving forward. So I went ahead and designated a periodic table. I found one that's pretty similar to what we're looking for. And so notice these other elements that we did not shade in. They just shaded it in as pretty much other nonmetals and the metalloids, which we're going to do a separate periodic table because the one that you've already shaded in is very crowded right now. So we're going to do a second periodic table that just talks about metals versus nonmetals shortly. But there's a couple other things you need to know. You need to write this in your notes. Sometimes, and I think this might show up on your homework, sometimes you'll be asked about representative elements. Representative elements are the elements that we use the most often. These include all your most of your biological elements like carbon, nitrogen, oxygen, fluorine. This includes a lot of the elements that are mostly found on Earth. So groups 1 and 2 and groups 13 through 17 include what's called your representative elements, which is most of your S and your P block, actually. You should also note, you already wrote this in, but just to have it in your notes, your transition metals are found in groups 3 through 12, and the F block doesn't really have a group number, so we just say that the intertransition metals are just your F block metals, because they don't have groups designated for them on your standard periodic table. They're broken off to the side.
Right.
so we're gonna answer a few questions on the next slide. And in here, I wanna also ask for the number of valence electrons, just to see if you've got the handle on what to do with that. Giving a little bit more time here, about 30 more seconds, and then we're gonna move forward to some practice questions.
Wait, transition metals. Can I also just put D block?
Sure. And they do have group notations. It's 3 through 12. But it is the same as group block. Okay, so write these questions down. The question is, what group is each of the following elements in? I also want to know how many valence electrons. Let's practice with that. This is a common type of question you'll need to be able to answer. For any element in the S&P block, you need to be able to figure out how many valence electrons you have. Yes?
So aluminum, gallium, indium, is that in non-transition metals?
These are post-transition metals.
Post-transition.
All of these are called post-transition. And, by the way, besides the PowerPoint notes, if you are looking for the group designations, they are on this front periodic table. I will be covering this on the day of your exam, but beforehand, if you're studying, you can use this to study.
Wait, what are group designations?
Like alkaline earth metals, just classify the different groups.
And
Post-transition metals are there.
do we answer those questions on the
Yeah,
paper?
answer the questions on the paper. Because this one, there's not an ability to answer on your pad. This is answer on the paper, and I'm going to go over it with you. Pretty quickly, though. So what group is each of the following elements of strontium? First of all. So it's called the alkaline earth metals. Okay, sure. Alkaline earth metals, that's good. Earth metals. And my second question is, how many valence electrons then does strontium have? All you got to do now is look. You don't have to write the whole electron configuration. You just look for the group that tells you how many valence electrons it has. Strontium has.
Wait, Miss, whenever you say that, what group is each of the following elements? Isn't it the number?
You can say the number or the name of the group.
Oh.
Let's go with the name just so that we're practicing with it. What group is chlorine in? They're called the halogens. And how many valence electrons does chlorine have? 7. Because it's in group 17, you just take away the 1. And that tells you that it's 7 valence electrons. Neon. What group is neon? Overall acid. How many valence electrons? 8. Sodium. What's the name of the group? Sodium. It's 9.
Isn't the alkali what?
So it's the alkali metals. And how many valence electrons?
1?
Now I'm going to warn you. I'm going to give you a trick question so you can figure it out. What about helium? The name of the group and how many valence electrons does it have?
Double gases?
Double gases. How many valence electrons does it have?
8.
The answer is 2. Although helium is in group 18, because it's in period 1, and because it is helium, it only has 2 electrons. It cannot have 8 valence electrons if it only has 2 electrons in total. So helium, you want to write that down. It only has 2 electrons. Because it's short, DC is shorthand for because it only has 2 electrons. It cannot have 8 valence electrons. It is 1s2. Maxes out at 2. Energy level 1 maxes out at 2. So that's a trick question I could give you. So you think that'll show up on the quizzes?
Yeah.
Hydrogen would be 1.
Wait, that thing.
Because it only has 1 electron. It can't have more than 1 valence electron. It has 1 electron.
And that
That's
only
its 1
happens.
valence electron.
That only happens for helium.
That's why I pointed it out. What you learn in this class is, you have the rule and then you have exceptions. The periodic table can help us with most things, but then you have to think about the exceptions. and why they are what they are. So the last thing you're gonna figure out, yes.
So you refill hydrogen now?
You're about to. On the second periodic table I'm giving you today. I told you there would be two, right? Told you the first one, you run out of room to write what you need to. And what I'm about to teach or reteach you is so important. It should get its own periodic table because all chemical bonding and reactions depend on if the elements combining together are metals or if they're non-metals actually. So we should know our metals versus our yes. Go ahead. Whether we have metals or non-metals by looking at the element's position on the periodic table. So this is the second. Thank you. Thank you. This is the second periodic table. This is the last one you're receiving today, but not the last one you're receiving. Keep that blank for now because you're about to fill it in. On the second periodic table because we have run out of space. There you go. At the top of this second periodic table, you're going to write something different. You're going to write the top of this one, so I'm going to get out of here to get rid of the. So we're going to fill in another one. Second periodic table, 3 colors is all you need for this one. This is metal / non-metal. It's so important you know the metals, the non-metals, and the metalloids. We want a separate periodic table for it. This is where you're going to shade hydrogen in. Yes, you need one piece. I always miss that row when Jason's not here because there's nobody. So non-metals and non-metals. Metals and non-metals. Yes. Yeah, the other title would have been classification. So the first periodic table you should have titled classification of elements. For the first one. If you didn't title it, you should title it classification of elements for the first one. And the second one is metals / non-metals, which we're about to fill out now. The first one is how do we classify elements into their groups and subsections? And now, how do we look at an element and see if it's a metal and a non-metal or a semi-metal, which means in between the metals and the non-metals. So here we go.
Yeah, so it's like a half metal.
Yeah, it's like a half metal, actually. It is a lot like that. And once we see the trends, it'll explain more about why that's so. But for now, we're just classifying. So practice with that dividing line. Where does it start?
At the corner of Oreo.
Right. That's where you have to imagine it is. Are you allowed to request a periodic table on the next unit exam to write on?
Yeah.
Yes. On the next exam, you're allowed to have, it's going to come to you blank, but you're allowed to
Right.
write on it. And that's exactly how the Cambridge exam is. You get one you can write on. Like, it will be the same as the laminated one. The only reason I have them laminated is I don't want you to write on that one so that everybody in all the classes can use it. But when you take a test, you're allowed to ask for your own credit table to write on. Got it? All right. So we're going to start a dividing line at the top corner for boron. And the way it works, one line over, one line down. One line over, one line down. And I'm telling you twice how to do this because I want you to memorize it.
Why is negative X?
Kind of. But it's a step function.
Oh.
It's a step function. If you think of it math-wise, but we said that this side is the, and this side is the non-metal. And so the next thing is you're going to pick a color. Pick 3 colors. One for metals, one for non-metals, and one for metalloids. I'm going to pick my first color for metalloids. I'm going to fill in the center section first. I'm picking green. So I'm picking green and calling those the metalloids. Where exactly are your metalloids? On your staircase. They are the elements that are on the left and right-hand side, except for 2. There's 2 exceptions. Alpha, aluminum, and polonium. Those are actually metals. So we're going to shade in our metalloids. I'm shading them in in green.
Wait, what does metalloid mean?
Semi-metals, meaning sort of like a metal, sort of like a non-metal. So once we learn the properties, which is the last thing we're going to go over today, they have some properties of metals and some properties of non-metals that are individual to each element. So metalloids in green: boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. And then these two down there, which would be tennessine and oganesson. Just that they don't really they've been created in the past 10 years. So. I'm gonna pick a second color. I'm gonna pick blue. I'm gonna pick blue for my non-metals. Which side of the periodic table are the non-metals on? The right. So starting at carbon, and like this, all of these, including helium and hydrogen. These are all non-metals. Carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, sodium, bromine, krypton, and then pick a third color. I usually pick gold because gold is a metal. And although most metals are silver, I don't have a silver marker.
We have to memorize all this.
Yes. So your metals are on the left-hand side of the staircase. All of these elements that are white right now, I'm going to shade them in. I'm shading mine in gold. You can shade them in whatever color you want. All of these are metals. So most of the periodic table is made of metals or non-metals.
Oh.
What do you think? Looking at the elements.
Yep, metals.
Mostly metals, right?
I feel like non-metals are blue.
Non-metals are bullies. We're gonna learn that next class. They're like, I'm gonna steal your electron.
Oh wait, not wait, I thought non-metals were
We'll talk about that next class. That's where we're going. All of these livermorium, livermorium, Laurentium,
Is that one for two or is it just?
all of these. Yeah, this one too. I did.
Oh,
Yeah.
oh, okay.
Oh. So, the easiest way to do this is to write the staircase and to remember your metals are to the left and your non-metals are to the right.
And then somehow remember the middle.
And remember the metalloids. The way that I memorized it is it's all the elements to the direct left and right of the staircase except for alpo. And I remember alpo because that's a brand of dog food.
What's Alpo?
Aluminum and polonium. Alpo. Those are metals. They're the only two on the staircase that are not metalloids. Alpo.
Oh.
That's how I memorized it because I don't like memorizing a lot. So I just memorize a little bit and I'm like, I got it. Use my resources. You've got a periodic table. So just imagine where these areas are.
Good job.
When I messaged you, you'd be coloring. Did you think you'd be coloring this much?
So we only need like 3 colors. It can be fun, but
Yes, tell your friends all we're doing is coloring the periodic table. In like 20 different sections. Almost ready to go? All right, so the last thing we have to discuss is, well, what is a metal? Like, what is the point? What is the difference between a metal and a non-metal? What's the point of doing this? And so that's the last thing we're going to discuss today is what is the key differences between metals and non-metals, at least at an elementary standpoint, like at a foundational standpoint. Where do we start with this? Because we're going to talk about metals and non-metals a lot over the next couple of months, but where do we start? I'm going to wait 30 more seconds. I still hear pencils going and crayons going, so I'll wait 30 seconds and then I'm going to move forward. So do you have to memorize all of these designations and sections? Yes. You're allowed to ask for a periodic table to shade in when you get the test? Yes. You want to pre-order? Yeah, pre-order, right? That's funny though.
Did I use the game points to get on a table that they all filled out?
I've never heard anyone ask that before. That is a friend at a game.
That's actually a good game. Comedy show.
It was like, get an actual
My own
periodic.
periodic table.
So you had to memorize this entire thing.
Where am I going to? Where did you ask me to go to? This is where we're at. All right. So definition. You need to know properties of metals, and so there's a few properties here that you have to know. Metals themselves, which is most of the elements of the periodic table. Metals are good conductors, meaning that they transfer heat and they transfer electric current. So they transfer heat very well and they transfer electricity very well. You can know this if you touch like the metal part of your car. If you've ever touched that, it gets really, really hot. You don't want to touch it because it can burn you. But that's how we know it does conduct heat. It absorbs heat very well and transfers it very well. So it transfers to you. It also conducts electricity. So all the electrical cables are made of metals. Like inside of the rubber cables, inside of there are metal wires, typically made out of copper. Copper is in the wires. Many metals are also, so there are some other points here that you should know. Metals are also ductile. That means that we can form metals into wires. I believe I've shown you magnesium wire before, and it was a coil. It's like coiled into a wire. The other thing about metals is they're malleable, which means you can bend them without breaking them. I said it in the second period. I felt like it sounded poetic. Being bent without being broken. Are you a metal today?
Wait, most metals?
Most metals.
So not all of them?
Right. Most.
You know which ones that they can?
I would say mercury.
Oh. Is it like the liquid metal thing?
Right. I know. I could tell you mercury for sure.
I'm finally done filling out the medals.
Yay. So, 3 things you gotta know about metals. They are very good at conducting both heat and electricity. They can be drawn into wires, and they can be bent without being broken. That's the word malleable. That's what it means. Are you malleable? Word of the day. And so we actually know that the elements on the periodic table, most of them fit the properties of metals. So what is a non-metal?
Like plastic?
No metal. Yeah, plastic's made out of non-metals actually. It is. It's a gigantic chain of carbons and hydrogen. That's what plastic is. It's a bunch of carbons and hydrogen. 10,000 carbons and hydrogen.
Oh.
10,000 plus is what plastic polyethylene bags are made of. That we get at the grocery store. That are terrible for the environment. Terrible. A discussion for later in the year. In general, go ahead, this is what nonmetals are. What you need to know about nonmetals for now is simply that they do not conduct electricity well at all. There is a very, very notable exception we're going to learn about. Not yet, but we will learn about. Nonmetals are poor conductors of heat and electricity. They are known as insulators. So we wear non-metal clothing. We do. Unless you're wearing armor.
Yeah.
Unless you're wearing armor, your clothing is made of non-metal, which means that you're not going to get electrocuted from your clothing. And it keeps you warm. It doesn't transfer heat very well. It keeps it in. It's an insulator. Whether it's cotton you're wearing or polyester, our clothing's made out of non-metal. Unless you wear armor on a daily basis. And the to know about nonmetals that's really important is in comparison to metals, nonmetals have a great variation in their physical properties, meaning that a lot of your nonmetals are gases, some of them are liquids, and some of them are solids. Whereas with your metals, almost every single metal on the periodic table is a solid, with mercury being the lone exception, yes. At
Okay,
room
I was
temperature.
gonna ask, there is no gas metal?
There's no gaseous form of metals at room temperature. But you can make anything a gas if you try hard enough. Meaning you apply enough energy to it, you can vaporize anything.
Miss, what happens if you eat what happens if you eat a little bit of acetylenoids? What if you
Of
eat
what?
what if you eat uranium?
If you eat uranium, I would have to visit you at your funeral, most likely. I'm so sorry.
What if you eat a
You're
tiny
really
bit?
bad time.
What if you eat a tiny bit?
Like a thin little, I don't know.
Like a tiny bit.
I don't know that one would go out. But you can't even measure one atom. Like 1 times 10 to the negative 30th gram or
I'll eat
something.
this much.
That's a lot. That's a lot. All right, last definition in the classwork. You may be able to do this as classwork because this is the last slide for the day. Metalloid is the last. Actually, there's going to be an activity we're going to try at Nearpod after this. We'll see if Nearpod works. A metalloid generally has properties that are similar to both those of metals and nonmetals. They're right in between. They're in the middle. So this means that we also call them semimetals. And you might have heard them called semiconductors. A lot of materials are made out of semiconductors, like silicon chips.
Silicon chips.
Not the chips you eat,
Oh.
like computer chips.
Yeah,
Silicon-based chips. Computer chips.
Would you eat silicon flavored chips?
I don't think that's good for you. Let me tell you. Hold on a sec. Hold on a sec. Hold on a sec. I have silicon. It's right here.
No, that thing. No, it smells bad.
It's not sulfur, it's silicon.
Oh.
Here. Don't eat it. Oh. You can touch it, but don't eat it.
Oh, I thought it was rubbery. It's sticking my hand. Look.
Oh. Yeah.
I thought it was rubbery.
We try to eat
Elements, yeah. Just don't eat it. But no, we do not eat. Rest for now. It's just something to keep on your desk.
You take my hand.
Did you notice it stained your hand? Touch it.
Okay, so
Let's talk about that. It looks like a rock. Right? Keep it. Don't eat it. You can keep it. Don't eat it. Just like you wouldn't eat a rock, right?
Okay, this naturally need.
What are some properties you see about silicon?
yeah, you don't eat it. You need to wait until you make it into a chip first. Then you eat it.
Different type of chip.
Miss, is it expensive?
Did I give you one or no? Did you get it? Okay.
Is
All
it
right.
expensive?
So, it's cheap enough for me to give out. Did you get it? Oh, sorry about that.
Silicon's the new best friend.
Your new pet rock. Silicon. Yes. Don't eat it. Really stay here.
Yeah.
No. Not in the regular salt, no.
The more you say don't eat it, the more you
No.
you more appetite.
All right, so it says, do not eat.
Do not give this monster.
Trophy has
It says, if swallowed, call a poison center.
it. Oh.
So, do not eat. Let's keep that
okay,
clear.
so
So, but I want you to notice something about it. Did you get some on your hands? Because I did.
I did so. I don't want to.
it's too
Where's silicon?
um,
Group 14. What else is in group 14?
carbon.
Carbon. All right. Carbon is better known as graphite. You know what graphite is?
Pencil.
Pencils. So although silicon is not exactly the same as carbon, not very well. Some of the properties are, in fact, similar because elements in the same group have similar physical properties in general. So it's shiny. Do you notice that it's shiny?
Yeah. It's shiny.
It's shiny. So you have your own pet silicon rock. Give it an 8.
Okay, so
Yes.
you said that if you swallow it, it's called poison control.
Yeah,
What
let's
if
not
you
do that.
already swallowed it 10 hours ago?
How is that even possible? All right. Try this last exercise on Nearpod. See if it works. See if it works. So you gotta be logged in, right?
Oh, yay, character. I see a character.
I mean, you can send the book.
It's blank for you guys. Try Nearpod.
Yeah, it's just loading.
If you're on a school,
It's working. Time to climb.
I don't see it.
Let's go.
Try Chrome. At least one person has it working on Chrome. Yes.
I used to track that with this at work, so when I use it with anything else.
Things are disgusting. They're like disgusting.
Are you on your phone?
Like the profile.
Are you on
pictures
your
do
phone?
not compare.
Yeah.
This is the
Pick your
camera.
character. We're gonna play something called Time to Climb.
You get the little,
Yeah.
Some
Some quick questions. Each one you'll get 30 seconds for. Have your periodic tables ready. You're gonna have to be fast.
The characters are disgusting.
You don't like your characters?
No, like they have mint.
They are
head.
chocolate chip head.
Everyone's a cookie or a dinosaur. Like, it's the only one that matches.
All right. Make sure you're getting into Nearpod. This is the final activity for the day, and you do have an assignment. This is digital assignment, just so you're aware before we go. Homework posted. It's not on paper. It's digital. It's that type where you have to take a screen capture when you're done and submit the screen capture. It's through the Science Week resource. So it's on classification of the periodic table. You may.
Yeah, I can. Okay. I'm excited.
All right, I'm hitting start in 30 seconds. So make sure you've chosen your character within the next 30 seconds.
Can we make a pencil out of this?
You could make a
A bad pencil. A bad
could work
pencil.
well.
Miss, my character is literally a dinosaur thing with a penguin body.
All right, starting in 5, 4, 3, 2, 1. Time to climb. At the carnival. So which of the following is a non-metal? Can you find the non-metal?
I'm right.
It's easy.
Come on. Oh, don't copy me. I'm not copying you. Look, it's not working.
It's on the right-hand side.
I'm pressing it. It's not letting me press it.
It didn't let you press it?
Hello? Nice job.
Wait, what?
Oh, now it lets me.
It didn't let you. Aw. All right, Kevin's in the lead. First question.
Non-metal.
What's the element in group 2, period 4? Group 2, period 4.
I did first. What are you talking about? I literally did it more first than you.
Group 2, period 4.
Why do you need to translate my page? No. Who's here? Look, I'm here. I'm cooking it. Why am I the last one? Wait, do you get
All right,
game
question 3. Which of the following is a chalcogen? A chalcogen.
I don't like these. I just looked at it.
Look on it. Uh-huh. Trying to distract. Chalcogen. Chalcogen.
Like you basically.
All right, next up. Group question 4. How many metals are in this list?
The best chance you guys guess and then get it right.
I think 30 seconds may not have been enough time.
Where's boron?
Where's boron?
Oh.
Where's boron?
Wait, does it count half boron?
Boron's another way.
Miss, I don't think we'll.
Where's
Yeah.
francium? Wait, francium. I'm guessing. It's 2.
It's 3.
It's
It's
3.
3. I guessed it. I guessed it.
Yes.
I guessed it.
3.
I'm first. No.
Question 5. Which one's not a property of metals?
I already got it.
We just went over this.
I already got it. Easy.
Which one's generally not a property of metals? Not a property of metals.
I think it's that. 'Cause I'm so
Once you pick an answer, it's over.
Look.
It is a property. Wide variation in properties is a non-metal.
Just shiny.
Metals are generally shiny.
Nothing else to shiny.
How many valence electrons does nitrogen have? Did we figure out how to do that? Can we do that fast now?
Yeah. I can do it in 0.2 seconds. I can do it in 0.2 seconds.
All right. We've got one more question.
Please, I hope the first person gets it wrong.
Tyrone's in the lead now with one question left.
I second.
Last question. How many valence electrons does calcium have?
Easy, easy, easy. Okay, so back up. We have no time to
There is
celebrate.
no restarts. But I will play you out to the periodic table.
Yes, do
early.
Whoever's third, can we can we gain points? Miss, you should come back for the
Elements of the periodic table.